Hey, I'm Dale. I'm an engineer that works on AI on Google Cloud.
And I'm Torry. I'm also a developer on Google Cloud AI.
Thanks for coming to our talk. So if you work at Google, being in AI or machine learning is a really good field because sometimes it seems like it's the thing that everybody's talking about everywhere. When you say you work on ML, people think about the Google Assistant or Waymo's self-driving cars or AlphaGo, which was our algorithm that beat the world champion at the board game Go. But even besides these very high-profile projects, machine learning is in almost every app within Google, from translation to photos to Gmail. And if you just look at the number of internal Google repositories that use machine learning code over the past 5 years, it's absolutely skyrocketed.
What about AI beyond Google? Well, for a long time, there's not as much machine learning outside of Google, because machine learning is a complicated field. It often requires specialization and possibly advanced degrees. And frankly, there are few people with such specialty, but there are a lot of developers like us. Not to mention, there's the hardware aspect and the DevOps component of it. Even if you find all the right people, you have to worry about where to put these compute-intensive workloads. But at Google, we want to democratize machine learning. We don't want to gatekeep developers from using machine learning in their application simply because they don't have the training or the machines to do this. That's why the topic today is machine learning without data science expertise.
Oops. But first, let's talk about what machine learning actually is. The way that I like to think about it is just finding patterns in data, which might sound pretty simple, but you can actually build lots of awesome applications with that concept. Like, for example, the algorithm that recommends you music based on your past listening history. Or maybe you want to forecast trends or build AlphaGo, a board game playing algorithm. Or maybe you want to do a task called classification, which I'll focus on because it's sort of the canonical machine learning application. Classification is essentially just labeling things. Maybe you have pictures of cats and dogs and you want to assign them labels. And the way that you normally do this is roughly the same. You always build a model, and that model usually starts with a labeled training data set. So you'll have lots of pictures of all sorts of different breeds of cats and all sorts of different breeds of dogs, and you want to have as diverse a data set as possible because the more your model knows about the world, the more accurate it will be. You feed this into some machine learning algorithm, and out pops a model. And if you've done a good job and if you have a lot of data, hopefully when you show that model a new picture of a dog, it's able to correctly label it as such. But if machine learning truly is, as I say, finding patterns in data, that means you probably kind of need data.
Well, what if you don't have data? Does that mean you can't use the model? Well, if you don't have data, Google has got your back. You can use one of Google's models. Here's a handful of models. Here's a handful of APIs that we have that you can use. I'm going to quickly talk about one or two of them, and then we'll jump into some examples and demos. So there's Cloud speech to text, which is converting speech audio into text, and there's text to speech, which does the inverse, converting text to audio. And then there's also Cloud translation, which basically exposes Google Translate as an API. Now let's jump into an example right away. So Cloud Natural Language, what does it do? It allows you to analyze text. So here we have a couple news article titles, and we want to make some sense out of it. So let's hop into the demo we have here. Could we switch to the, oh, there we go. All right, so the first demo I'm going to show you is actually the landing page of the natural language API. So there's a bunch of content you can read, but what we're really interested in here is the demo that's embedded in the web page. We've copied and pasted the first news article, and let's click Analyze to see what we get. And I'm not a robot. All right, so it returns these information about entities, and there's some internet accounts. They consider it other, there's models, they consider that consumer good. And there's 4 or 2, those could consider numbers. You can also take a look at sentiment. So the sentiment in this sentence is generally pretty positive. You can also take a look at syntax if you want. But what we're really interested in today is the categories. So if you look at this, it kind of corresponds with computers and electronics, which makes sense. Could we get back to the slide deck? All right, so if we look at the first news article, computers and electronics, but if you pass the next two articles into the demo I showed you, you'll get these two other categories. And all of this can be done using a HTTP post request, which really simplifies your life. You don't have to go back to this web page every time you want to get information about your news article titles. And you can use the similar REST API to analyze images. So here we have some images about ice cream or dogs. If you were to let Cloud Vision analyze these images, it will tell you, well, they're ice cream and dogs. It's pretty cool.
The Video Intelligence API is like the other APIs Torry mentioned, but it analyzes video. So for example, it can track objects and put them in bounding boxes. It can transcribe any text that was said in a video. It can also detect explicit content. And to show you an example of using this tool, rather than the curl request that Torry showed you, I'll show you how to do this in JavaScript. And it's quite concise. You actually just call the Video Intelligent client, and then you upload your video to the Google Cloud, and you pass the Video Intelligence client the link to that video in the cloud. Then you'll also pass it the features that you want to use. So in this case, I'm like, OK, can you label this video? So tell me all the different objects that you find. And then when the API returns, it will give me data in the form of, oh, there was a dog that appeared between seconds 3 and 5. But rather than talk about this, let me just show you how you can use it to build an app. This one is a shout out to my colleague, Zach. Thank you for building this. Can we go to the laptop, please? So here's our Video Intelligence app. And we use the Video Intelligence API to analyze all sorts of data about videos. So I'll tell you what it does, and then I'll show you because of the audio. So first, we transcribe the entire video. And we're also able to track objects in real time. So let me show you a demo of this.
Today we're at Starbucks with Google's Made with Code to teach girls how to code a lovely emoji onto our hot chocolate.
I'm dragging the emoji into...
It changes my perspective of code.
If you want to go into computer science, you be that person to decide that. Don't let anyone say no to you.
And that's the Video Intelligence API. Let's head back to the slides.
All right, so we've seen a bunch of off-the-shelf APIs. But what about custom tasks? Let me explain to you what I mean by custom task. So we've seen, given a picture of a cat, you give it to the Cloud Vision API, and you get back this response. That's really great. But what if, given the same image of a cat, you want to give a mystery API, and you want to get back this result, Mancoon? Well, this is specific to your use case. This is not something the Vision API anticipated you might need. So in this case, you're going to need to train your own machine learning model. Well, it turns out this is a fairly long process, approximately these number of steps, right? I'll quickly walk through some of these steps, but don't worry if it's complicated, because it is. All right, so first you have to gather and pre-process all these data and group it into these different cat breeds. And then you have to split the data set up into a training set and an evaluation set. And then you have to build your TensorFlow or Keras model. You have to build the model, and then you have to train the model, and then you have to evaluate the model. And finally, with the model, you have to deploy it somewhere, maybe in the cloud, maybe on your phone, just so you can get to the final step of making a prediction. Just so you can upload a photo into the API and get the result you want. Let's just say Mancoon, right? So in reality, you just want to get from step 1 to step 7 as fast as possible without all of the intermediate steps. Well, have y'all seen this ad? if it's a chore, right? So you want to make Google do it. Make Google build your model for you. That's where Cloud AutoML comes in. What is Cloud AutoML? Cloud AutoML allows you to bring your data and give it to AutoML. AutoML will take care of training, deploying, and serving your model. And all you have to worry about is querying the REST API. And if we go back to the 7-step process I showed you, it really simplifies the whole process. You get your problem, you get your data, and you make a prediction. All those intermediate steps, Cloud AutoML will solve it for you.
Today we're going to build our own custom AutoML model to do a task called object detection. That's when not only do we want to know what's in a photo, but we actually want to know exactly where it is. We want to find the bounding box. And today we're going to build a model that identifies clothing, just like we've done on Sundar. So how do we do it? First, we need to find a labeled data set like Torry mentioned. And to do that, we went to Kaggle, which is a website for data science competitions that also happens to host lots of awesome free public data sets. And so we found almost exactly the data set that we needed, clothing item detection. So it had all pictures like this, and human beings had labeled pants, shirt, etc. So this really helped us get started. But there was a problem because these photos are a little bit unnatural. Everybody's just standing on this white background. And so when we try it on us in real space, the model doesn't work as well. So to fix this problem, we augmented our data set by actually uploading our own photos and outlining boxes of our clothing. And we did that for a while, but then to make the process even faster, we sent our photos to Google's data labeling service, which is a feature that can have Google annotate your data for you. So to see what this looks like, you write a set of instructions in a PDF of how you want your data to be labeled. So you'll say, for example, I'm going to give you all these photos, put a box around my jacket, but if I'm wearing a shirt underneath the jacket, don't include that. So you send your instructions to raters, and the results that you get back look something like this. I'm sorry I just dumped this huge spreadsheet on you, but basically it's what we found in the photo and where the box that surrounds it is located. Now, let me show you how we actually go from that to building a model. Let's hop to the laptop. So here I am in the AutoML Vision UI. Now, there are two different types of models we could train. One says just labels a photo, cat or dog, but object detection, like I was telling you about, actually puts the box around the items. So our first step is to upload our data set, which I kind of showed you, just to give you a closer peek. I'm going to expedite that a little bit. So here are some of our data. I'm going to hop into a photo of our colleague Paige. And if we wanted to label this data set ourselves, we actually just click and drag around the thing we want to label. And then we say, this is a top. And then we save it. Great. Now, definitely preparing your data set is the hardest part of building a model with AutoML. Training is actually pretty simple. We just hop into the Train tab. We click Train New Model, and then we can select different features, like do we want a more accurate model or a faster model. And then we click Start Training, and then we'll get a message that says something to the tune of, we're training a model for you, check back in 4 hours. And then in 4 hours, you get an email that says, take a look at your model. In this Evaluation tab, we can see how well the model did. So most of the time, it will be better at detecting some clothing items more than others. So let's just investigate how it did on T-shirts. Now, there are lots of statistics that are useful to evaluate your model here, but I'll just show you the most useful feature for debugging, I think, which is seeing the examples of your model labeled correctly and incorrectly. So these true positives are correctly labeled as T-shirts. But here are some false positives. So it thought these were T-shirts when they're not. To be honest, I think it's kind of hard to tell the difference between whatever. But this will help you debug your model and see where you need more data. Then to actually use that model, you can test it out within the UI. So I'll just show you uploading a mirror selfie of myself. That's me. And there you go. You can see it's never seen this photo before, but it can kind of guess where my jacket is and where my jeans are. Now, in addition to just trying this out in the tool, you can call this model the same way we did the other APIs, either through a curl request or in a number of client libraries. So Google handles all the complications of actually hosting your model in the cloud. So let's hop back onto the slides. So what is actually going on under the hood when AutoML builds that model for you? Now, this talk is machine learning without data science expertise, so this is unnecessary. You can cover your ears. But in case you're just curious to know what's going on under the hood, well, our photos are being classified using something called a neural network. But the first step before we can feed our data into an algorithm is that we have to go from a photograph to numbers. So suppose we have a photograph of a cat. Well, that photograph is actually made up, if it's digital, of pixel values, red, green, blue, which correspond to numbers. So using those pixel values, we can convert our photograph into data by making it into 3 arrays of red, green, and blue pixel values. Then that is the input to this, which is a diagram of a neural network. And admittedly, I'm going to sort of go over this very quickly. There are other great talks that talk about it. But basically what's happening is those pixel values are being added, multiplied, combined, scaled, and then passed to a higher level, and then passed to a higher layer. And eventually, a number comes out that says 80% dog, 20% cat. And at first, the model doesn't know how to combine those numbers, but as you show it more and more training examples, it becomes more accurate. If you're interested in this, I definitely encourage you to explore more. But normally, training a model to do this, if you were to do it, as Torry said, from scratch, takes a lot of data, probably more data than we had, which was something like under 200 examples. But luckily, when you use AutoML, you're not using just your data. You're actually using Google's models that have been trained on lots more data. So you can have a very high-quality model, even if you don't have that much data to work with. And these neural network technologies power lots of Google machine learning products like speech-to-text, that's transcription, translation, and object recognition. AutoML also has lots of different data types you can pass besides just images, so let's talk about that.
So yeah, one of our new products is AutoML Tables. It was just freshly announced last month at Google Cloud Next. And what does AutoML Tables do? Well, it deals with structured tabular data. So let's just say there's this table here, and you have strings, timestamps, numbers, classes. And what you really want is just predicting the target column. So this is actually a data set of a marketplace. And people are selling things on the marketplace. We want to predict how much those items are sold for. Well, it turns out there's a data science competition for just this very specific task I described. And before I tell you how AutoML Tables performed in that competition, we actually graphed the results of every contestant on this visualization here. On the x-axis, we have the ranking. So the more towards the right, the better the team did. And then on the y-axis, we have the error. So the closer to the bottom of the chart, the lower the error. So if you think about it, the better contestants have lower errors, which makes sense, and the worst contestants have higher errors. And here's how AutoML did. In just an hour, AutoML Tables is able to surpass the median competitor. And given 11 more hours, given 23 more hours, AutoML can do better. And what is interesting, and something I want to point out, is that all 3 of these 1 hour, 12 hour, 24 hours is on the plateau, which I think is where like the data science enthusiasts and data science professionals hang out. So that's really cool for AutoML Table to be able to achieve such results.
So Torry just told you about tabular data, but what about text, which is an extremely common type of data? For that, we can build a custom model using AutoML natural language. And there are actually lots of different types of natural language models that we can build. So we could build a classification model. So maybe we have US congressional bills, and maybe we want to categorize them by what they're about. We can build a custom model to do that with AutoML natural language. And then at Next last month, we actually released 2 new types of models that we can build. The first one is custom sentiment. So maybe you remember that Torry showed you that the natural language API could take a sentence and tell you whether it was positive or negative. But if you train your own custom model, then you can learn very terminology-specific things, like that waiting on the tarmac is bad, but having lots of legroom is great. You can also build a custom entity extraction model. So again, out of the box, the API can take a string and tell you what entities are. For example, it knows that I, Dale, am a person, and a cappuccino is a consumer good, and it doesn't really know what a croissant is. But if I wanted to make a model that really understood foods, I could do that and maybe say that cappuccino is a beverage and identify that croissant is a food. And to do that, you create a data set much like the one I showed you for object detection. But to do this, you actually take strings of text and you label them in line and you say, this is a food, this is a beverage, and so on.
So let's review. Today, we showed you that if you don't have data, you can use one of Google Cloud AI's APIs. But if you have data and you have your own custom use case, you can use Cloud AutoML. And we showed you how to build custom models with different data types. Here are some links for you to visit.
We hope that what you take away from this is that you can play with machine learning while focusing on building your app and not on building your model. Because you can get started with these tools really quickly, probably in under an hour, and you can build awesome things with them. So thanks for coming to listen. We'll hang out here to answer questions right now, I guess.
All right. Thank you all.